let's see if we can figure out what this pressure is. Notice this dimension, this diameter, is 4 times bigger than this diameter, which means this radius is 4 times bigger than this radius. Since area is equal to, assuming this is a circular cross-sectional area, is equal to pi r squared, that means that this area here is going to be 4 squared times bigger than this area, or 16 times larger. So this area here is 16 times larger than that. Given that the volume flow rate is constant because conservation of mass, we know that if we have area 1 V1 would have to be equal to area 2 V2. And if this area is 16 times larger than this one, that means that this velocity here has to be 16 times smaller than this velocity. So if this velocity here is 8 meters per second, this one here is going to be 16 times faster than that. So 16 times 8, that's 128 meters per second at that location. So I can use Bernoulli's equation, P1 plus 1/2 rho V1 squared plus equals P2 plus 1/2 rho V2 squared. So this one we know its pressure is 300,000. Let's assume this is water, so half of 1,000 would be 500. 500 times V1, which is 8 meters per second squared, equals P2 plus 1/2 of 1,000, which would be 500, times 128 squared. Then I can solve this for P2. Another version of this exact same problem would be if instead of giving us what P1 is, if they connect these two with a U-shaped pipe. Kind of like this, I guess. Do a very good job of drawing that, but I think you get the idea. And there could be another fluid in this. Maybe it's not necessarily water, maybe it's mercury or something. This is higher over here. And realize this difference in height here can help me figure out what the gauge pressure is. So when I'm going back to Bernoulli's equation that I had a second ago, 1/2 rho V1 squared equals P2 plus 1/2 rho V2 squared. Realize that this right here, where I know what the density of this is, I know what this height is here, H. That really would help me figure out what the gauge pressure is, rho GH. Well, the gauge pressure is just simply going to be the difference in these two pressures. P1 is going to be a higher pressure than P2. So P1 minus P2, which is the gauge pressure, rho GH, would be equal to 1/2 the density V2 squared, that's right here at this point, minus 1/2 rho V1 squared. So looking at this, again, 1/2 of 1,000 would be 500. And if you remember, we said the velocity there was 128, so 128 squared minus 500 times 8 squared. That will give us what the pressure is, the pressure difference, the gauge pressure. And I can set that equal to rho GH and I can figure out the height, or if they gave me a height, I can figure out the pressure and work backwards and figure out the velocity.